Here we have the definition of one-to-one or injective. A function f is one-to-one or injective if for all xi, xj in the domain, the following statement is true. If xi does not equal xj, then f of xi does not equal f of xj. Now this is the defining property for when a function is one-to-one. And the thing to remember is that this is a for all. All right, what we're saying is for all or for every xi, xj, this thing happens. All right, so let's investigate that a little bit. Now, I think it's really instructive to see a function that is not one-to-one and to see where it fails this property. All right, so let me draw a function, a bubble diagram for a function that is not one-to-one, and then we'll see why it doesn't, why it's not, why it fails this property I've circled in blue. All right, so over here on the left, this is our domain. This is our target, which is the same thing as the codomain. And notice that in our domain, we have 5 x's. We have x1 to x5. So what this tells us is that I and j are ranging from 1 to 5. So I think it's somewhat confusing what this xi and xj are right here. And when we say for every xi and xj, what we're saying is if we were to label everything in the domain as x1 to xn, however many things we have in there, then I and j can be any of these numbers between 1, in this case, between 1 and 5. So that's the idea there. Okay, so remember that I and j are between 1 and 5. Now remember, what I'm going to draw here is not one-to-one. That's important. All right, this function here that I've drawn, and we could give it a name, call it f. F is not one-to-one. So let's see why not. Let's see why it fails this if-then statement. And to see why it fails this if-then statement, let's use our truth table for if-then. Now, if we're looking at our truth table for if-then, this would be our P, this would be our Q. Okay, so we have xi does not equal xj, f of xi does not equal f of xj, and lastly we have P implies Q, right? So this is like P here, this is like Q, and then lastly we have P implies Q. So we have xi does not equal xj implies f of xi does not equal f of xj. Whew, I was able to fit it all in there. Okay, so we have true, true, false, false, true, false, true, false. And remember that P implies Q is only false when we have true P and false Q. So we have true, false, true, true. Now our function here fails to be one-to-one in only one spot. It fails to be one-to-one right there. Now let's see why. Okay, so it fails to be one-to-one for x1 and x2. So in this case, my I is 1 and my j is 2, which gives x1 and x2. Right, so we have x1 does not equal x2, and f of x1 does not equal f of x2. Now it's important for me to note that what I'm writing here for what I'm writing here and here, I'm not necessarily writing true things or false things. All I'm doing is writing something. All I'm doing is writing something. And then if it is false, then the truth table will tell us what happens. If it is true, the truth table will tell us what happens. That's the idea. All right, so now let's look at this. Let's say, okay, does x1, so is it true that x1 does not equal x2? That is true, right? If you could see here, right, that I've drawn x1 and x2 as two different things. So x1 and x2 are not equal. That is true. They represent two different pieces or two different entities in the bubble, right? x1 does not equal x2. So our P is true. So our P is true, so we can eliminate all of the rows where P is false. So we can eliminate that row, we can eliminate that row. Okay, now let's look at Q. Is it true that f of x1 does not equal f of x2? All right, well, let's see real fast. So what is this saying? So our y1 here, look, y1 is equal to f of x1. And y1 is also equal to f of x2. So putting those together, that tells us that f of x1 equals f of x2. But our Q is that they're not equal. So our Q is false. So that means we can eliminate this row. And so all we're left with is that P implies Q is false. It's false for x1 and x2. And remember, this is the defining property for this. The thing that makes this the defining property is that it's for all xi and xj. So our defining property does not, we found a place where it is not true. It's false. It's not true for every xi and xj because it's not true for x1 and x2. That's why this function is not one-to-one.